Hi everybody, welcome to UNS EduTech's physics concept sessions. In this session, we are going to discuss about one of the most important concept in class 10 physics, that is Ohm's Law. So Ohm's Law is the relationship between voltage and current in a circuit. So before going to the mathematical details of Ohm's Law, I will explain you a simple system, a simple circuit where we can verify the concept of Ohm's Law. So I will show you the circuit, schematic circuit. Then I will take you to the actual physical experiment and we will verify Ohm's law before going to the mathematical aspects. So here you can see we have a power supply, a DC power supply is there, direct current, then we have a switch or a key, then that is connected to a rheostat. Rheostat is a variable resistance, this is called rheostat. That is connected across a resistor and the circuit is completed through an ammeter. Ammeter is always connected in series with the circuit and a voltmeter is connected in the system. So now we are going to vary this rheostat resistance. If you are varying the resistance, what will happen to the voltage and current reading in the voltmeter and ammeter? So we are going to do the actual experiment. Let us see the setup. See here you can see there is a voltage supply or the power supply. Here this is a DC power supply, we have positive and negative terminal. The positive terminal is connected to a rheostat. Rheostat is actually a variable resistance. The rheostat output is connected to an ammeter and which is connected in series, and then connected to the ammeter output is connected to a resistance, and the resistance is connected back to the power supply so that the circuit is complete. Now across this resistance we are connecting a voltmeter. So here the circuit, whatever schematic you saw on the board, we recreated that exact circuit in the experiment setup. So here if I switch on this power supply, you can see if I give the power to the system, you can see the voltmeter, ammeter as well as voltmeter is showing some reading. Now if I am varying this resistance of the rheostat, so if I am varying the resistance, if I increase the resistance, less current will pass. If I reduce the resistance, more current will pass through the circuit. So here you can see if I am reducing this resistance, you can see both ammeter and voltmeter readings are going up. That means both voltage and current is going up in the system. So same way, if I am increasing the resistance, you can see that is reducing both current as well as voltage is reducing in the circuit. So here we saw that there is a direct relationship between voltage and current. That means it's directly proportional. If voltage is increasing, the current is increasing, so or vice versa. You can see if voltage is reducing, current is also reducing. This particular relationship is called Ohm's law. Now let us go to the mathematical aspects of Ohm's law. Here if you are making a graph of current versus voltage, it will be a linear relationship because we saw that voltage is proportional to current. If you are increasing current in the circuit, you can see voltage is increasing in the circuit. Okay. Or if you are trying to make an equality, we can write down simply voltage is equal to a constant into current. Or we can say V will be equal to R into I. This R is a very special constant that is called resistance of material, or R is given as the ratio of voltage divided by current across that particular resistance. So this law is called Ohm's law. Here we can see if I am plotting I versus V, you can take the slope. Slope is nothing but if you are taking a small section, if you are taking the small change in current happen, this is nothing but delta I, this is small change in the voltage, delta V. Now if I am taking the slope, slope is nothing but rise by run. So slope is usually represented by the letter M, that is delta I divided by delta V. So here already you know that V by I is equal to R, or you can say we can say here I by V will be equal to 1 by R. So here the slope of this IV curve will be 1 by R, or if you are plotting V versus I, the slope will be equal to R, or rise by run, that will be V by I will come, that become resistance or R of that circuit. See here one of the important concept you have to understand. Here you can see that this is a linear curve. So because the relationship is directly proportional, this is the linear and this law is an empirical law. Empirical law in the sense this is not applicable across all material, because it is applicable only for a short range. For example, copper from particular temperature to some other temperature, or are applicable for certain material. So, it is not applicable for entire material. Such laws are called empirical law, because F is equal to ma is a physical law which is applicable everywhere. This law is not like a physical law, is different, is applicable for only for a short range of material or short range of physical parameters. So, always remember, Ohm's law is not a physical law, it is only an empirical law. Through experiments we are finding out the variation of I against V for a short range, and is applicable for only certain materials. For example, copper if you are considering, that is an ohmic conductor because it is exactly obeying Ohm's law. And for example, semiconductors like silicon or germanium, if you are considering, that is not obeying the Ohm's law, we call it non-ohmic conductor. I hope all of you understood the concept and the mathematical principles behind this law. Now, let us see one simple animation so that you will get much more idea about Ohm's law. Here we have a conductor and a voltage source, you are completing a circuit through some wires. Now, I am fixing the resistance. For example, here I am fixing at 493 ohms is the resistance, and here voltage, if I am changing the voltage, see, you can see if I increase the voltage, you can see that the current is also increasing. Now, if I reduce the voltage, you can see the current is reducing. Now, if I am maintaining a constant voltage and if I change the resistance, you can see the more resistance, the current value will be less, and the less resistance, you can see current value will be more. Okay. So, this shows that how the voltage and current are related, and how this law, the Ohm's law, what is the underlying principle. Okay, I hope all of you understood this concept. Now, you can easily apply this for competitive exams. You can remember using a small trick. See here, this one is called Ohm's triangle. So, in this triangle, if you are writing R on the right side, the resistance on the right side of the triangle, okay, then V, we can say voltage on the, see near, you can say an inverted V is here. So, V we can write down here, I on the left side. You can see I will be equal to V by R will be equal to V by I. So, you can see R will be equal to V by I will be equal to V by R. Now, V will be equal to IR. So, this trick you can use to understand the concept of the equation, you can quickly recall in competitive exams. I hope all of you understood the concepts. Now, if you wish to learn science like this through experiments, animations and simulations followed by lucid mathematical explanation, so that you will be thorough with your concepts and you will be sharp with your analytical capabilities, and you will start developing a habit of independent thinking and original thinking. So, you can join in our courses. UNS EduTech is offering online and offline foundation courses for competitive exam aspirants, and you can do one thing, you can go to the Google link given below. So, in that you can enroll your personal details, and our counselors will get in touch with you, or you can call to any of the numbers given at the end of this slide. So, you can talk to our counselors and get more details. I hope all of you enjoyed this concept, and I hope all of you understood this thoroughly, and you can subscribe to our channel and stay tuned with us, and we will soon come up with a new video. Thank you very much. Bye.